Topic 2 is titled Excluding Numbers from Rational Expressions. So we kind of have to really dive deep into what does that mean. Okay, at the beginning of this worksheet, we talked about the definition of a rational expression. So a rational expression is the quotient of two polynomials. That is, a rational expression is written in the form P over Q, where P and Q are polynomials, as long as Q does not equal 0. And we know that Q cannot equal 0 because division by 0 is undefined. So recall, well, I already have it typed there, so I don't need to write it out. So we need to recall that division by 0 is undefined, and this is huge. And this is something that we're going to have to, I'm not going to say worry about, but we have to be considerate of and think about when we get into a later section in this chapter where we talk about solving rational equations. So let's go ahead and think about what this means now so that when we have to apply it later, we've already seen it and it's kind of fresh. So division by 0 can't happen. So if I have a number, let's say x, divided by 0, that is undefined. We cannot divide by 0. And the issue with these rational expressions is that we have algebra in the denominator. So we don't have just a single number. We can't just look and be like, that number is 12. It's not 0. So instead, we have these algebraic expressions where we have these variables that represent some unknown value. And we, the mathematicians, have to be cognizant always of what values for the variable would cause this denominator to be 0, and we have to avoid them like the plague. Okay, so part of what we need to learn right now is how do we determine what values could cause a denominator to go to 0? So a rational expression is undefined for values of the variable that make the denominator 0. So we have to make sure that our rational expression is always defined, and to do that, we avoid the values that would cause it to be undefined. To find these values, we set the denominator equal to 0 and we solve. So this is kind of like what we're going to do, okay? Now, these values for the variable are called restricted values. So these are the values right here. So these are the values that cause a denominator to equal 0, which make the expression undefined. So when we're talking about rational stuff, rational equations, rational expressions, this is very much like talking about fractions. You're going to see a lot of these key components that we learn with fractions show up again here, but we have to learn how to apply that with algebra. So again, we can look at a fraction and very easily look at the denominator and be like, it's 0 or it's not 0. With a rational expression, we have to be a little bit more careful. We have to do some work to figure out what values for the variable are problematic, what values for the variable are restricted values, and those are the values that make our denominator 0, which would cause the whole expression to be undefined, which is not a good thing, okay? So in order to do this, we just take our denominator, set it equal to 0, and solve. So let's look at example 2. It says, find the restricted value for each rational expression. Well, the restricted values, again, are the values that make the denominator equal to 0. So when I look at part A, I have 5 over x plus 2. What value for x would I plug in there that would cause that denominator to be 0? Well, you can glance at this one and see, well, x equals -2 would be bad. If I plugged -2 into this denominator, I would get -2 plus 0, or -2 plus 2, which is equal to 0. Well, having a denominator equal to 0 makes the whole expression undefined. We don't want that. So the way we do this is we take the denominator and we say, okay, what would make this equal to 0? So we take the denominator, we set it equal to 0, and then we solve for x. So I've got x plus 2 equals 0. I need to get x alone, which means I need to subtract 2. 2 minus 2 is 0, leaving me with just x. 0 minus 2 is -2. So the restricted value here is x equals -2. Why? Well, if I plug -2 back into this expression, so if I evaluate, like we did in the previous video, if I evaluate for -2, bad things happen. So we're going to evaluate for -2. So I get 5 over -2 plus 2. Well, that's 5 over 0, which is undefined. Let me actually scoot that over so we have room for the full word undefined. So I have 5 over -2 plus 2, which is 5 over 0, which is undefined. undefined. Okay, so that is why x equals 2 or x equals -2 is bad. So my restricted value here is -2. Okay, let's look at part B. So part B, we have a bit more going on. We have 8x over x minus 3 times x plus 1. So the directions say, hey, take the denominator and set it equal to 0. I think it's off the screen. Well, no, it's right here highlighted. To find these values, set the denominator equal to 0 and solve. So I have my denominator equal to 0. And notice it's already factored. I have a product that's equal to 0. So I can apply the 0 product property. Well, if I have x minus 3 equals 0, to get x alone, I would have to add 3 to both sides. So 3 or -3 plus 3 is 0. X plus 0 is just x. 0 plus 3 is 3. So if I were to plug 3 into this right here, I would get a 0 right here. So when I plug 3 in for x, well, 3 minus 3 is 0. 0 times x plus 1 is 0. That's going to make that denominator 0, which is bad. We don't want that. Now, if I have x plus 1 equals 0, to get x alone, I subtract 1. Well, 1 minus 1 is 0, leaving me with just an x. So I get x equals -1. Well, this time, if I were to plug -1 in, right here, when I have x plus 1, if I plug -1 in, I get -1 plus 1, which is 0. 0 times x minus 3 is 0. That would make this expression undefined. So the restricted values here, well, let me go back to black ink. So the restricted values would be -1 and 3. Okay? Last up, we have C, which is 3x over x squared minus 2x minus 24. We already know from the highlighted directions at the top of the screen that we want to take our denominator, set it equal to 0, and solve. Well, we get to practice what we learned in the previous chapter. So right here, we have a quadratic equation. It is in standard form. In order to solve this, we need to factor the left-hand side and then apply the 0 product principle. So in order to factor the left-hand side, I luckily have a coefficient of 1 on the squared term. That means we can do the shortcut factoring. So I just need to start two binomials, each with an x. And then I'm looking for factors of -24 that have a sum of -2. So in order to have two factors of -24, one has to be positive, one has to be negative. And in order for them to have a sum that is negative, the larger of the two factors needs to be the negative factor. The smaller needs to be the positive. So I could do -24 and 1. I could do -12 and 2. I could do -8 and 3 or -6 and 4. So of these pairs of factors, which pair adds up to -2? Well, this pair right here. So I want to go -6 plus 4. Now I have a product that equals 0, so I can apply the 0 product principle. If I have x minus 6 is 0, I need to add 6 to both sides. 6 minus 6 is 0, so I get x equals 0 plus 6 is 6. And if I have x plus 4 equals 0, to get x alone, I need to subtract 4. 4 minus 4 is 0, leaving me with x equals 0 minus 4, which is -4. So my restricted values would be -4 and 6. Okay, so we want x to be anything but -4 and 6 for part C. For part B, we want x to be anything but -1 and 3. For part A, we want x to be anything but -2. Okay, so again, restricted values are values that make a denominator equal to 0. And once the denominator equals 0, that expression is undefined, and we do not want that. We cannot have division by 0. Division by 0 is bad. Okay, so make sure you understand what a restricted value is and how to find a restricted value for a rational expression.